use the Taylor series formula, that is the definition of Taylor series, to determine Maclaurin series for the following function. Function is x times e raised to x. So this is the Taylor series expansion, Cn, but our center is 0 because Maclaurin series. All we need to determine is Cn, and Cn's are given by this formula. Nth derivative of the function, evaluate at 0, divide by n factorial. So we will determine C0, C1, C2, C3, C4, and based on those we will write down, we'll find a pattern, and that will be our Cn. So let's do it. So first we need C0 because n starts from 0. So let me make a table like en values. N equals 0 means we want to find Cn's, that's the goal here. So C0, and we need to find derivative, nth derivative of the function. That's the most important or complicated part here, and we need to evaluate at center, which is 0, Maclaurin. Okay, so n equals 0 means 0th derivative, which is function itself, so just ex. Now evaluate at 0, so plug in 0 for x, so 0 times e raised to 0. E raised to 0 is 1, but 0 times 1 is just 1. Oh, 0 times 1 is 0. So C0 is 0 over 0 factorial, but just 0. N equals 1, we need to find derivative of this, which is a product. So let's use the product rule to find the derivative. A derivative of x is 1. Now x alone. Derivative of ex is just ex. Now we can factor ex out, 1 plus x. Okay, so derivative 1 means 1, first derivative of the given function is here, e to the x, 1 plus x. Let's evaluate at 0. So e to the 0 is 1, 1 plus 0 is 1, so 1 times 1 is 1. Then C1 is this 1 over, look at here, Cn is that value over n factorial. So C1 is 1 over 1 factorial. Let's write that. Since, look at here, C0 is 0, so when we write this series, the very first term will be 0, so this sum will start n equals 1 for us because the very first term will be 0, C0 is 0. So C1 is 1 over 1 factorial. Let's find C2, C3, and then we should have some type of nice form. Okay, so n equals 2 means we are trying to determine C2. C2 will be something, whatever we have here, divided by 2 factorial. Okay, we need to find derivative. 2 means second derivative of the given function, which is derivative of this derivative, so which is here. So let's find this derivative. Okay, already some work is done here, so let's find its derivative. E to the x, 1 plus x. If I find its derivative, again I got to use the product rule. Derivative of ex is just ex, 1 plus x, plus derivative of 1 plus x is 0 plus 1, just 1, and ex, we can factor ex out. That leaves 1 plus x plus 1. That means 1 plus 1, 2 plus x. Okay, so derivative of this is e to the x, 2 plus x. Now let's evaluate at center, which is 0. So e to the 0 is 1 times 2 plus 0 is 2. So this is 2. So C2 is 2 over 2 factorial. Looks like we got a pattern. C0 is 0 over 0 factorial. C1 is 1 over 1 factorial. C2 is 2 over 2 factorial. If C3 comes out to be 3 over 3 factorial, then we are good. Then we can confirm. But we need to determine C3. 3 means C3 will be this value divided by 3 factorial from the formula. We need to find derivative of this product. Again, is simply e to the x, 2 plus x. So let me just make it slightly different. It will be same thing, and it will be same thing. 2 plus 1, it will be 3. So derivative of this product is e to the x 3 plus x. Now evaluate at 0. E to the 0 is 1 times 3, which is 3. Okay, C3 is 3 over 3 factorial. So I think we know CNs, okay, all CNs. So we can confirm. So from these three, C1, C2, C3, we can just say, okay, then Cn is simply n over n factorial. I mean, n is now 0, 1, 2, 3, 4, anything. But n over n factorial can be simplified. It's n over n factorial means n times 1 less factorial, n minus 1 factorial. Why we want to simplify it? Why I want to write this way? So that I can cancel. So this is simply 1 over n minus 1 factorial. And by the way, our n starts from 1, 2, 3. Okay, because very first term is 0. Because when I cancel, I cannot cancel 0, 0. So I'm saying n equals 1 to 3. So here is the Maclaurin series, and our Cn is 1 over 1 minus 1 factorial. Okay, thus the answer. So the function x ex is in fact equals some n from, not from 0. Look at very first term was 0, so 1 through infinity of Cn, which is 1 over n minus 1 factorial xn. Okay, that's the answer. But what we can do is we can always start from 0, or equivalently we can write the answer as we can start from 0, so I have to subtract 1 and add 1 here. If I add 1 to the n, okay, this is plus 1 into n minus 1 plus 1 inside, then when I do plus 1, I can start from subtract 1. That way I can start from 0. Not necessary, but a lot of times we want to start from 0. So that gives 1 over n minus 1 plus 1 means n factorial x n plus 1. This is fine. This is also fine. Final.